I'm asking us on the board here to do two things. First of all, draw a circle whose center is at 3, -1 with radius 2, and then find an equation for that circle. Okay, so if I go to graph this, here's my point 3, -1. Now I'm going to initially just plot a point there. I'm going to erase it at the end because the center is not a point on my circle. But I kind of find it helpful to have that as a reference point as I'm trying to sketch things. Now I want the radius to be 2. So I know I want the set of all points that are a distance of 2 from this point. So I'm going to get something round, okay? What I like to do is just sort of see how high up and how low down I'm going to go and how far to the left and to the right before I try to sort of connect the dots. Because I could just sort of say, oh, it's going to be something round centered there. I haven't really paid a whole lot of attention to what the radius should be, and I've just drawn something that's too big. Okay, so if the radius is 2, then my highest point would be 2 points directly above there. My lowest point would be 2 points directly below there, and I'd come 2 to the left and 2 to the right. Just doing that helps me to see that this circle will cross the x-axis because there are points above it as well as points below, but it will not cross the y-axis because there's nothing to the left of the y-axis. Okay. In this case, it's going to be far enough away from the y-axis that I probably figure that out anyway. But that can be helpful because anytime I'm graphing, the x and y-axis are really my frame of reference. So now I'm just going to draw a circle. Good enough. With these as the highest and lowest points and these as the points furthest to the left and to the right. Like I said, let's go ahead and erase that center because it's not actually a point on the circle. Okay, so there's my graph of the circle. Now I want to find an equation for it. I also want to find a different color marker. I have succeeded in that. Okay, so in figuring out the equation, I'm going to think through the Pythagorean theorem again. So I am going to go ahead and draw back in that center 3, 1. Again, that wouldn't be part of my graph of the circle, but now I'm using that graph to find the equation. Okay. And I'm looking at a point, x, y. I'm going to purposely not choose the points that I used in graphing that are directly above and below or directly to the left and the right of the center. If I do that, I know that the length of that line segment has got to be 2 because that's a radius. That's going from the center of the circle to the outside of the circle. And then if I just go straight to the right and straight up, I've created a right triangle. Now I'm going to just draw a larger version of that triangle over here. This was at the point 3, 1. This we said was at a point x, y. So now, because the center isn't at the origin, the length of this line segment here is no longer just x. It's going to be the difference between x and 3. Now, as I've drawn this, x is to the right of 3, so this length would be x minus 3, but I'm going to just label this as the absolute value of x minus 3. That way, if I had chosen a point over here so that x was actually smaller than 3, the distance would be 3 minus x, but that's the same as the absolute value of x minus 3 in that case. I can subtract in either order as long as I take the absolute value. This vertical distance is now the difference between y and 1. Again, as I've drawn this, for this particular point, that would just be y minus 1. But in general, I can say that's the absolute value of y minus 1. And then we said our radius was 2. So the Pythagorean theorem gives us that the absolute value of x minus 3 squared plus the absolute value of y minus 1 squared is equal to 2 squared, which will be 4. So I do need to be careful. With the unit circle, the radius was 1, the radius squared was the same thing. If the radius isn't 1, it's the radius squared that's going to show up when I use the Pythagorean theorem. All right, and then now the absolute value becomes unnecessary because I'm squaring. So this is just the quantity x minus 3 squared plus the quantity y minus 1 squared is equal to 4. Okay. And again, this will correspond to the Pythagorean theorem for every point except these points right here that are directly above or below or to the left or to the right of the center. For those points, if I just took a look at this point, for example, this would be, we'd come just 2 straight to the right, so that would be the point 5, 1. So 5 minus 3, that would be 2. 1 minus 1 would just be 0. But that's still going to satisfy this equation. Those just give me the degenerate triangles where basically I shrink one of the legs to 0 so the other leg is the same side as the hypotenuse, except it doesn't really make sense to talk about legs and hypotenuses if I don't actually have a right triangle. Okay, so that's going to be my equation for this particular circle. Okay, and we can generalize that. Now, I like working through it with the Pythagorean theorem because that helps me to remember so that if I ever forget the formula for the equation of a circle, I can figure it out. But it's kind of nice to generalize the result. If the center is at a point HK and the radius is equal to R. Now I can actually draw a picture of this if I want to. Now, of course, I don't know where HK is, but just for the sake of argument, I could put it there. Okay. And the radius is R. Okay, so that distance has to be R, and there's a point XY. Okay, right there, I get my Pythagorean theorem. Now that triangle would have R as the hypotenuse. This leg would be the absolute value of x minus h. This leg would be the absolute value of y minus k. And when I apply the Pythagorean theorem, this squared plus this squared is this squared. So that's going to become x minus h squared plus y minus k squared is equal to the radius squared. So, some of you are already familiar with that equation. Some of you are going to like to memorize that. What I kind of like is accidentally memorizing it. Thinking through this process of the Pythagorean theorem often enough that you just kind of remember the result, but then if you ever forget it, you can figure it out again. Okay, so let's just take a look at an example. What are the center and radius of x plus 3 squared plus y minus 1 squared equals 9. So I can take a look at the center. Now I just have to be careful because the coordinates of the center are the numbers that I am subtracting from x and from y. So if we're adding 3, we've certainly seen this before, that adding 3 is the same as subtracting negative 3. And then here we were subtracting 1, so the center would be at negative 3, 1. Okay. And the radius, just be very careful because that's the radius squared, so the radius would be the square root of 9, which of course simplifies to 3. The radius will always be a positive number. By definition, the radius is a distance, and distances are always positive. All right, so that gives me the general equation for any circle. I can put the center wherever I want. The radius can be any positive number.